Free response number 3 is asking you to find the convergence of the series. It says which, and it doesn't tell you which test to use. You can pick whichever one you want. So we have the summation from n equals 4 to infinity, cosine 1 over n, over n to the 1 over n. So we need to prove convergence or divergence of that series either way. So in this case, I'm really not sure about this series. We could probably do some kind of comparison test. We could probably do some kind of limit comparison test. There's a couple different things that we can try. However, when I'm not sure about a series, I always find it's best to start with test for divergence. Test for divergence is really good because if you take the limit of it as n approaches infinity and it's anything other than 0, it automatically diverges. So it really kind of saves you a lot of steps if the series is already divergent. So let's go ahead and start with that. So first off, I'm just going to write out what TFD is. So TFD, remember it says that if I take the limit as n approaches infinity of a sub n and it comes out to anything other than 0, it's automatically divergent. So I'm going to go ahead and take the limit of this as n approaches infinity. So limit as n approaches infinity, cosine 1 over n to the 1 over n. So now I just need to figure out what these series are going to do as n approaches infinity. Well, cosine of 1 over infinity is going to go to 0. Cosine of 0 is going to end up being 1. So I know that this first term will just end up being 1. But now I need to figure out what's going on with this term. So I have n to the 1 over n, and I need to figure out what that's going to do. Well, as it turns out, there is a rule that says that if I take the limit as n approaches infinity of n to any constant over n, the limit of that is always going to be 1, no matter what the power is. So n to a power over n is always going to be equal to 1. I have n to the 1 over n, 1 is a power, so n to the 1 over n is also going to be 1. So when I take the limit of this whole thing as n approaches infinity, I end up getting 1. 1 is not equal to 0. Because 1 is not equal to 0, this series diverges. By test for divergence. Or you could also call it the nth term test. There's a couple. But regardless, the series diverges by nth term test or test for divergence.
The Teaching Center, UF's Learning Resource Center.